Hey, seventh graders, we are doing spiral review number 8 today. And I am going to start off with your quick question in the corner. What is one of your greatest dreams for your life? Sometimes my questions are maybe a little corny or sometimes random, but if you think about those things in your life, it's really important so that you can make the most of what you're doing and kind of keep your eye on the prize. Like if you have something that you want to do, maybe you want to be a chef, maybe you want to work on automobiles, maybe you want to be a stay-at-home mom or something like that. It doesn't matter, but what you need to do is think about how you can do that thing successfully, how you could be the best at it that you can be. And so it's important to kind of keep those things in mind. So sometimes I like to ask those questions. So let's get started with our spiral review. Scale drawings is the first thing that we are looking at. And we've done scale drawings in class. It was a lesson that it was a part of something bigger and we flew on by it. So I wanted to make sure we revisited this. In this problem, it says Ricardo drew some scale drawings. What scale factor did he use each time? So in other words, we have something small that became something bigger. And he needed to make sure that if he is going to, let's say he's drawing a map of a room that he's going to paint or something like that. Maybe he drew it out and it was 4.5 inches or 4.5 inches on its width, but then in actuality, maybe the actual thing is much bigger, right? In this case, not that much bigger, but because no one has an 11.25 inch room, I hope, but you never know, maybe in a dollhouse. So that is going to be able to help you understand scale factors. So what you need to do is think about what number did he multiply 4.5 by to get 11.25, to get bigger. And it's going to be something more than one, because it's more than the original size itself. Now, if it got smaller, it would be a number less than one. Like if I multiplied by 1/2, it would be good. The dimensions would go down by 1/2. Okay, so in other words, what we can do is say, okay, 4.5 times some number, and that's going to be an X to represent that number. 4.5 times a number is going to equal 11.25. Okay, and then we just solve it like we normally solve equations. Okay, we look at what is happening to our variable. 4.5 times what number? Let's get rid of that 4.5, undo it. If it's beside it, divide it. So I'm going to divide away that 4.5 on both sides. Keep things nice and balanced, right? It's an equation. It's like a balance. If we're going to do something to one side, we have to do it to the other. So I'm going to cancel that out. And now X is alone, and we're about to get our answer. Okay, so 11.25 divided by 4.5 is a scale factor of 2.5. And if you're not sure, check. Is 6.5 times 2.5 going to be 16.25? Let's check. 6.5 times the scale factor that we found of 2.5 is 16.25. So that checks out. So the scale factor is 2.5. That's 2.5 times bigger than it originally was. So you're going to do number 2. Okay, compare either one of those corresponding side lengths, set up the equation, and solve. Then on the next set of questions, it's on proportions or some similar ideas to proportions. It says Anna is clearing brush from a large piece of land. The table shows how many acres she has cleared over time, because we measure land in acres usually. So we've cleared this amount of bushes or this amount of bush, and then in these amounts of days. So we have relationships between her rate of cleaning and clearing the land. So it says, how many days does it take to clear 1 acre or 2 acres or 3 acres? So if you can figure out one of these, it's even easier to figure out some others. So let's go ahead and do just 1 acre right here. So I know that she in 2 days can clear 2/3 acres brushes. So I could put the 2 on the top or on the bottom. It doesn't matter as long as I set up this proportion. There's more than one way to do this, but this is how I'm doing it on this one. The acres cleared over the days that it required. Okay. So for 1 acre, if I want 1 acre cleared, how many days did that take? Okay. I don't know that. So that's going to be my X. Okay. And we do a lot of the same things in 7th grade over and over. We use a lot of different proportions for different kinds of problems. So this is the same thing. Okay. I'm going to go ahead and do cross products. I'm going to cross multiply. 2/3 times X is going to equal 1 times 2. 2/3 X equals 1 times 2, which is 2. Now I just have to get my X all by itself. Well, when it's beside it, we divide, right? Dividing by 2/3 is actually the same thing as multiplying by the reciprocal. So if I multiply by 3/2, my 2's cancel out and reduce. 2 divided by 2 is 1. 3 divided by 3 is 1. So that's why we use that scale so that we can get rid of it. X is going to now equal whatever 2 whole times 3/2 is. So you could put 2 over 1 if you want to. I'm going to write it just a little bit bigger up here. Okay. 2 over 1 times 3 over 2. I could simplify that. And it's just going to be 3 over 1 or 3. So 1 acre is going to be done in exactly 3 days. Okay. You might get fraction answers, so just be aware of that. Okay. Set up your proportion, acres to days, and solve the mystery of how many days it takes for these different amounts of acres. Next up is application. We know lots of things in math, right? But we need to be able to apply those things to understanding. So this one said, on Monday, the theater club sells 14 tickets for the school play. Not bad. On Monday for a Monday theater play selling. All right, on Tuesday, they're going to get 10 more tickets sold. So altogether, how many is that? Well, that's 14 tickets. Okay. Oh, sorry, 24 tickets. I was thinking it said 4 for a second. Okay. So if that is 32% of the total tickets, how many were sold in all? Okay. And then you're going to do 7. So I'm going to model it with 6, and then you need to do 7. So 24 is 32% of the total amount. So if those words sound familiar, you should hear the is over of equals percent over 100. Okay, is over of. So 24 is 32% of some bigger amount of tickets. So I'm going to rewrite that. 24 is, so I put it where my is 32%. So 32 over 100. My 100 is always there. Of what number? Well, we don't know that number. So that's the number that we're solving for. So I'm going to go ahead and I could reduce now. I see 32 over 100 could be reduced, but I'm going to go ahead and cross multiply. 32 times X is going to equal 24 times 100, which is 2400. And then if it's beside it, divide it. Man, that keeps coming up, doesn't it? We got to have those basic skills down. And so if I just do 2400 divided by 32, 75. Okay. 75 tickets in all. You can set the same type of proportion for 64%. So that if that was 64% of the total amount, how many are there going to be in all? And last but not least, probability. What's the probability if we roll double 6s? Well, this is called a compound event because there's more than one thing happening. So you have to think about each die. Okay. Dice is more than one. So one die is going to have a 1 out of 6 chance of rolling a 6. Okay. And the other die is going to also have a 1 out of 6 chance of rolling a 6. So what you do for those compound events is you multiply them times one another. So 1 over 6 times 1 over 6 is 1/36. For number 9, the last one, you're going to be doing this one. What's the probability of rolling 2 even numbers? So think about that first die. What's the probability that I would get an even number when I roll my die? And then what's the probability of getting another even number when I roll the other die? And then you want to multiply those 2 answers together to simplify. And that's it. Have a great day. Bye, guys.